So what is a limiting reagent, or called by some a limiting reactant? Simply put, it's any substance or anything used in the production of some final product that runs out over the course of the manufacture process. And of course, once you run out of something you need to build things, you stop building. And I always like to introduce it with a simple analogy that's easier for people to get a handle on sometimes. Let's say you're the manager of an auto manufacturing plant and you're producing sports cars. And each one of these cars has two doors. It's a jazzy two-door coupe, and one engine and four wheels, hopefully. And your inventory manager tells you that day that you have 300 engines, 400 wheels, and 500 doors in stock. How many cars could you plan on building that day? Well, a simple equation tells me that we need one engine and we need four wheels, which I'll abbreviate WH, and we need two doors, DR, in order to produce a single car. And now I can deduce how many cars I'm capable of making that day. You see, I do have 300 engines. And I'm going to need one to produce each car. So if I divide by that coefficient, I get the number 300, implying that I could produce 300 cars based on the engines. However, with 400 wheels, and the fact that we use 4 for each car, means that I could only produce 100 cars, at least if I wanted wheels on all of them. So far, the wheels are the limiting reagent. I'd use all 400 of my wheels after producing 100 cars, and that's it. I'd stop making cars. But let's just check if we have 500 doors, 2 each. We could produce 250 cars. So very clearly, my limiting reagent is the wheels. And I'm going to use it to figure everything out that I can do that day. For instance, I can now figure out how many cars I'm going to make, because I do know that for every 4 wheels, I can manufacture 1 car. So I can create a conversion factor out of the wheels and cars using their respective coefficients. Wheels cancel, and I get 100 cars, what I can actually produce. Now, there's a second question that could be asked, namely, will there be any unused doors left over at the end of the day? If so, how many? Well, of course, because I had enough doors to produce 250 cars, but we only made 100 cars, so we're going to have what's called excess, namely stuff left over. And to calculate the excess, I need two things. I need to know how many I started with, and then I'm going to have to figure out how many I use, because the excess is the difference. Namely, take what you start with, say I go to the store with 20 bucks, and subtract what you use, say I spend 15, then my excess would be 5 bucks, $5. And I do the same thing here in this process. How many did I start with? Well, I started with 500 doors. But to calculate how many I use, always make everything begin with your limiting reagent. I know that seems strange. It seems strange to start with the limiting reagent to do a calculation to find how much of some other reactants left over. But we do. We use our limiting reagent to calculate the amount used. And of course, in this relationship, for every 4 wheels, we should use 2 of our doors. So for 2 doors, we use 4 wheels. And I like to label that used, because I won't make a common mistake. And that means 200 doors are used during the day, and we manufacture, which makes sense. Making 100 cars, we're going to use twice as many doors, 200 doors. Now here's a very common error to look out for. This is a calculation of what we use, but when we're asking what's left over, that's not the answer. Instead, we look this way. How many did we start with? We started with 500 doors. How many did we use? We used 200 doors, meaning there are 300 doors excess by the end of the day. And I could have asked the same question for engines, but we'd have a different ratio here. It would be 1 engine for every 4 wheels, and we would have used 100 of our engines. And subtracting that with the 300 we started with, we'd have 200 excess engines. So, if we move along to stoichiometry now in chemistry, limiting reagent problems are really the same. You are building products out of reactants, and the coefficients indicate the relative numbers of things you use and what you produce. So anytime you have a problem where you're given amounts of 2 or more reactants, in other words, this is 2 moles of this reactant, 3 moles of this reactant. Now, just as in the case of building cars, we ran out of something first, and when we ran out of that limiting reagent, we stopped making cars. Well, one of these 2 chemicals is going to be limiting. We consume it and convert it into products. And when the limiting reagent runs out, the reaction stops. You make no more product. You can only make as much product as the number of atoms you had to make it with. So the first thing you have to do to answer a question on limiting reagent is find out who's limiting. Remember, we used our limiting reagent here to calculate not only what we got, but also to calculate what was left over. So we're going to do the same thing here. We got to find our limiting reagent first, and that's easy. If you have moles especially, which we've given, this is a simple starter problem, use the number of moles you're given and divide it by the coefficient. And when I divide 2 by 3, I get 0.667. Now, I don't label this. This is nothing. We're dividing moles by a coefficient, and this is no longer moles. This is moles. This is just a number, and I'll show you what to do with that number in a second. But first do the same thing for the other reagent. We have 3 moles to start with of boron trifluoride, and we're going to use 4 of them in the reaction. And when I divide 3 by 4, I get 0.750. Now, all I have to do, because what I'm doing is I'm taking how much I started with and dividing by how much I need. How much I started with dividing by how much I need. Now, if I compare the numbers that I get, the smaller of the 2 numbers will be the limiting reagent. In this case, my first reactant is limiting. So get moles, divide each by its coefficient, compare the values, smaller values limiting reagent. So what do I do now? Well, I answer the question, and everything's going to start with my limiting reagent. 2.00 moles of NaBH4. And I'm asking in this problem, how many moles of each product will I get? Well, the first one, B2H4, I know this guy's going to run out. I can make as much of that product as these 2 moles of reactant allow me. And I notice it's a 3 to 2 stoichiometric ratio. So I can get 2 moles of B2H6 for every 3 moles of NaBH4 that I use up. Meaning we'll get 1.33 moles of that product. And when we get 1.33 moles, all of our limiting reagent will be used up, and we can't make any more, because after all, that's where the part of the source of our boron is, but it's where all our hydrogen's coming from to make this compound. So we stop making it. How about the other product? Well, we start with the same limiting reagent, and we use a slightly different coefficient ratio, because for each 3 moles, we should get 3 moles of the other product. So we get 3 moles NaBF3 for every 3 moles, of NaBH4 consumed. And you multiply that out and you will get 2.00 moles of the other product. Yes, so I get 1.33 moles of this product and 2 moles of that product. Now, let me show you if I had not identified my limiting reagent first. Let's say I mistakenly thought BF3 was limiting. Well, then, if I reacted all 3 moles of boron trifluoride, and there's a ratio of 4 to 2 with the first product, that means we get 2 moles B2H6 for every 4 moles boron trifluoride. Meaning that we get 1.5 moles of the first reactant. Now compare that to how many moles we get using the limiting reagent. It is more. So yes, we are getting more product than we could actually get. We would have run out of hydrogen long before we ran out of boron and fluorine. So no, never use the reagent that's not limiting. You will get amounts that exceed what you can actually produce. Then in the second part of the problem, how many moles of which reactant will be excess? Well, that's no sweat at all, because of course the excess can be calculated if I know how much I start with and how much I use. Now remember, the boron trifluoride is my limiting reagent. So I start with 3 moles of boron trifluoride. And I'm going to use some of it up. And I have to calculate how much I'm going to use up. And I base all calculations on limiting reagent stoichiometry on my limiting reagent. So I start with the 2 moles of my limiting reagent to do the calculation. NaBH4. And then I use the stoichiometric ratio between the limiting reagent and the excess reagent to figure out how much I use. For every 3 moles of my limiting reagent, I should also use 4 moles of boron trifluoride, my excess reagent. And I label that used so I don't make the classic error. And so of course, it means I'll use 2.67 moles boron trifluoride used. And then I can figure out what's left over, because if I started with 3 moles and I use up 2.67 moles, I will be left with 0.33 moles of excess boron trifluoride. Now this makes sense too if you think about it, because we have to conserve mass. And notice that in our products we got a total of 2.33 moles of our 2 products, but we reacted 5 moles of reactants. So of course we have to have some excess. Now in the second part of the limiting reagent video, I'll discuss some slightly more complex problems.